picking up from the last video, part 1, part 2. So what we have is our formula. We've got volume equals length times width multiplied by height. And what we can do is when you fold this up into a little box, our height will be x. So I'm going to put that first. One of the lengths will be 8 minus 2x, and the other length will be 3 minus 2x. And then you're going to FOIL that. So I'm going to FOIL this first and then multiply by x. So the volume with respect to x, so 8 times 3, 24. 8 times negative 2x is negative 16x. Negative 2x times 3 is negative 6x. That multiplied by that is positive 4x squared, because a negative times a negative is a positive. And then you would multiply this x into the whole thing. So that times that makes 24x. That times that minus 22x squared. That multiplied by that plus 4x cubed. So here's our formula for the volume. Which, by the way, it was given to you anyway, but still good to practice doing it. So I just only noticed now that the volume formula was actually already given to you. So imagine you had to prove it. That's how you would prove it. Now what you're asked to do is find the maximum volume. So remember, what we need to do is we need to find the gradient function. This is the volume function, the original volume function. Now we need to find the gradient function. And to find a maximum, you set the gradient function equal to 0, and then you solve. So the original function's this. So if v of x is this, v dash of x will be, that's a x term, so it just becomes a coefficient, 24. 2 times negative 22 makes negative 44x. Subtract 1 from the exponent, x to the 1. 3 times 4 makes positive 12x. Subtract 1 from the exponent, you get a square. Because it's a volume, you set it equal, maximum volume, set it equal to 0. And notice here we have a quadratic, which we can solve by factorizing, or you could use polysmalt. Again, if you've forgotten how to use polysmalt, you need to go to apps, select polysmalt 2, which for me is my 4th one, press enter, polyroot finder, that's all good to go. Now just enter the coefficients. So what's important is the first thing that happens to appear is the x squared term. So you might want to rewrite this as 12x squared minus 44x plus 24, because in the first one has to be the coefficient of the x squared term, so 12. The next one has to be the coefficient of the x term, so negative 44. And finally, the last one needs to be the constant term, which is positive 24. And then you just click on here to solve. We've got 2 answers. We've got x equals 3, so write down one answer, x equals 3, and the other one is x equals 2/3, or depending on your calculator settings, you might have had, like for example, fraction decimal, you might have had 0.6 recurring. If you can see, you can change it to a fraction and decimal like that with the FD. So 2 answers, x equals 3, x equals 2/3. So what does that mean? We want to find what the maximum volume is. So you've got 2 answers. First of all, take the x equals 3 and substitute it back into the original volume function. Not into the gradient. We're not asked to calculate the gradient. We're asked to calculate the volume. So substitute x equals 3 into the original volume function, which is also given up here. 4 3 cubed minus 22 3 squared plus 24 3. Plug it in the calculator, just calculate the answer, and you get 18 centimeters cubed. And the other possible answer is substituting in 2/3. So remember, you can go 4 brackets, and remember you can go alpha y equals if you've forgotten how to do that. So go back to here. So go, what am I doing? 4 brackets. And remember, you can go alpha y equals, select numerator denominator, makes a nice fraction. So yeah, you can put 2/3 in there. And then go out of here. All to the power of 3. And so on. So you can enter the rest in and you can calculate this answer. Remember, you can go alpha y equals n/d to make the fractions. When you do that, you get to 3 sig figs, 7.41 centimeters cubed. So let's think, is there one answer that we should accept and one answer that we should reject? Let's see. So I'll just scroll down here so you can see. Whoops. Scroll down here so you can actually see it a bit better. So 2 possible answers for the maximum volume, either 18 centimeters cubed or 7.41 centimeters cubed. So let's think, why have I said that this one is impossible? So one thing could be because if you plug in 3, let's see, 8 minus 2 times 3, that's fine. That would give you a length of 6. But 3 subtract 2 times 3, do you see the problem there? that would give you a length that's a negative. So the reason why we had to, in a way, you didn't even have to calculate 18 centimeters cubed. You could just look at this and try plunging it in. So you could get a height of 3, you could get a length of 2, but you couldn't really get a length of 3 minus 2 times 3, which is negative 3. So that's why we have to reject this one. You can go straight out to rejecting that. But if you could possibly have a height of 2/3, that makes sense. You could get a length of 8 minus 2 times 2/3, that will give you a regular length positive answer. And 3 minus 2 times 2/3 will also give you a regular positive answer. So that's why we reject x equals 3, and we only accept this answer, x equals 2/3. So the answer to the maximum volume would be 7.41 centimeters cubed. That's why I've said impossible, so reject this one. This one's possible, so accept it. Okay, another application problem. A farmer wishes to fence off a rectangular paddock similar to the one that we saw in the part 1 video using an existing stretch of river. So instead of an existing wall, we've got an existing stretch of river, and here's our fence there, there, and there on one side. The total length of the fence available is 100, so x plus y plus x has to be 100 meters. Let x be the width. So let's call x the width and y the length of the rectangular paddock. Let a meters squared be the area. So just say that a of x is our area function. Draw a diagram. So you've got your river, you've got your rectangular paddock around here. It's got a width. Width is generally shorter than the length. So x is the shorter side, y is the length. Okay, so find an expression for y in terms of x. So as the wire fence is 100 meters long, this plus this equals 100 meters. So you could say x plus y plus x equals 100. That's something you could write. Or you could go 2x plus y equals 100. So if 2x plus y equals 100, maybe you want to write that first actually. Let's do that. So let's say 2x plus y equals 100. Good thing to write down to begin with, because the whole fence is 100 meters long, and the fence from the diagram is got 2 x's and 1 y. So in terms of an expression in terms of y, you could just rearrange this. So rearranging this to make it y equals, you would subtract 2x from both sides. So y equals 100 minus 2x. So that's why the answer here, an expression for y in terms of x, y equals 100 minus 2x. So we can still call this x and this x, but instead of calling this y, we can now call this 100 minus 2x, is that length there. Find the expression for the area in terms of x. So we don't want to have y in that. We just want to instead say y is 100 minus 2x. So remember, area is length times width. Always good to remind ourselves, area of a rectangle, length by width. And our width is x, and our length is y, but we want it in terms of x. So call it let x by whatever y is equal to, and y is equal to 100 minus 2x. So instead we'll say x brackets 100 minus 2x means the width here times the length. And notice I've called it a of x, the function a with respect to x for the area. Find the dimensions that will maximize the area enclosed by the rectangle. So by dimensions they mean the length and the width. So the width and the length. We want to just basically find out what is x equal to, and then we can calculate what the length is. So what we've got to do, and we want a maximum area, so we've got to use optimization. So a of x, let's look at our original function, our area function. Remember, before we do the calculus, before we find the gradient function, we need to expand first. That's what I've written here, expand first. X times 100 gives you 100x. X times negative 2x gives you negative 2x squared. So now this is still the original function, a of x. Now we're going to differentiate. We're going to find the gradient function. So a dash x equals, that's an x term, so it just becomes a coefficient, 100. And then 2 times negative 2 is negative 4x. Subtract 1 from the exponent, you get x to the power of 1. Remember, at a maximum or a minimum, you set the gradient function equal to 0. So as the gradient at a maximum is 0, put the gradient function equal to 0, and then you just solve. So to solve, maybe let's add 4x to both sides. So therefore 100 equals 4x, and then you just divide off the 4. So divide off both sides by 4, you end up getting 100 divided by 4 is 25. So x equals 100 divided by 4, so x equals 25. So you've found the width. The width is x, which is 25 meters. So the length, remember, is 100 minus 2x. So I said 2 times 25 is 50 meters, but 100 minus 50 is just 50. So you might have wouldn't, right, instead of and length equals, you probably should say 100 minus 2 times 25. So in case any of you don't have the volume on, let's write that here. 100 minus 2 times 25. See, 100 minus 2 times x, 100 minus 2 times 25, which is 50 meters, same answer. So dimensions are the width is 25 meters and the length is 50 meters, and that will give you a maximum volume if you do that. Let's keep going, more and more practice. Quite repetitive, a lot of geometry going on here, but it's still good to practice because optimization is very popular on the exam, particularly in paper 2. And if you can do them, that can really help boost your marks. A closed box has a square base of side length x and a height of h. So if it's a square base, then it's got the same side, same length and width. So you can call that length x and that length x because it's a square on the bottom. And it's got a height of h. Write an expression down for the volume of the box. So we can go volume is length times width times height. And our length and our width are x by x. So x by x times the height. Height there. And this is okay, x times h. But remember, a more elegant way to write that would be x squared. X multiplied by x gives you x squared. H, we don't write, because see, it's confusing having the multiplication signs. So just having x squared h is a lot better. So you can call it v equals, or you can call it v of x equals. Write down an expression for the total surface area of the box. So back to the geometry unit, remember the surface area is all the side lengths, all the areas of the sides added together. Remember, in a box like this, there's 6 sides in total. So total surface area, I think there'll be the bottom. The bottom will be x squared. The top area will be x squared, x times x. This one here will be x times h, xh. This one here will be x times h, xh. The one at the back here will be x times h, xh. And this one back here will be x times h, xh. So add together all the 6 side areas. This combines to give you total surface area, area with respect to x. That was the volume with respect to x. Area with respect to x is equal to that plus that gives you 2x squared. That plus that plus that plus that gives you 4xh. Nice, that's finished. The volume of the box is 1,000 centimeters cubed. So they're saying this volume equals 1,000 centimeters cubed. Express h in terms of x. So we can say this thing equals 1,000. So let's go volume equals x squared h equals 1,000. And then we can take this and we can divide it off. So divide both sides by x squared, we get h equals 1,000 divide by x squared. So see, we've found x in terms of h, we've just rearranged the formula. Then we're asked to use these answers. Hence, show that a equals 4,000 x to the minus 1 plus 2x squared. So this thing. So just basically sub this into there. So sub that into a of x. So what we do is a of x equals this. See this thing here? A of x equals that. And now this thing is equal to that. So this thing goes in here. So we go 2x squared plus 4x, and then h is that thing, this thing here. And then we can start to expand that, equals 2x squared plus 4x times that gives you 4,000x over x squared. So that becomes 4,000x over x squared. And then the x here and an x here cancels down. So you get 2x squared plus 4,000 over x, because there's an x cancelled from the top and the bottom. Almost there, we're really close. So now we have to flatten. Now flatten the function. So this is still the original function, 2x squared. This little thing here is x to the 1. So bring it up and make it x to the negative 1. So bring it up into the numerator, 4,000 x to the negative 1. So we have flattened it. And now we're going to do the calculus. So now I need to write this. Something I forgot to write here was, oh no, sorry, this is the original function, Dory. This is still the original function. We're just asked to prove that. See, this thing equals that. And we just put the 4,000, this thing here goes here, and this thing here goes here. And I just swap them over, the same thing. That's the original function. Now, sorry, in E, we're asked to find the gradient function, find the a dash of x. So here's the original function here. Now let's find the a dx. So -1 multiplied by 4,000 is -4,000. X, subtract 1 from the exponent, you get to the power of -2. And then 2 times 2 makes 4x, and subtract 1 from the exponent, you get x. So you could have this answer, which is the flattened version, or you can have this one, because see the -2, you can bring it down and make it x to the +2. Last one here. Calculate the value of x given that a minimum surface area. So take your gradient function, set it equal to 0. So that's what I did. I took my gradient function here, set it equal to 0 because it's a minimum surface. Set the gradient function equal to 0 and solve by graphing. So let's do that really quickly now. Clear. So y equals, let's clear that. Let's clear that. So here we do y1, graph in y1. So we have y equals, and then we go -4,000 x to the power of -2 plus 4x. And what goes here is 0, graph in y2. So y2, we have put 0, and you might want to go graph. So that's this thing here is graphing here. So we want to find this. Let's go zoom 6, zoom standard, zoom 6. It's spinning, 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 spinning. Taking a long time. Here we go. So maybe we want to go window. Let's make our x max more like 20. 20. Graph. See, it's still spinning, 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 spinning. Here's that function. And then here comes in red. This comes 0. Y equals 0. We need to find this intersect here. So go second, calc, intersect. So go second, calc, intersect, number 5. And go enter, enter, enter. See? Flashing here. Our answer is x equals 10. So x equals 10. Calculate the value of x that gives a maximum surface area. X equals 10 is our answer. And now you're just asked to find the surface area for this value of a. So now you're just going to sub x equals 10 into a of x. And a of x is this thing here. A of x is that thing there. So go 4,000, oh, this thing here. So go 4,000, x to the -1 plus 2x squared. That's this. So go 4,000, 10 to the -1 plus 2 times 10 squared equals 600 centimeters squared. Yay. And still moving right along. We've got another question here. You might want to pause and try this one yourself first. You're welcome to. Dog food manufacturer has to cut production costs. She wishes to use as little aluminium as possible in the construction of a cylindrical can. H represents the height in centimeters, X represents the radius of the base in centimeters. So from the formula book, remember the volume of the cylinder. If you look in your formula booklet, volume of a cylinder is pi r squared h, because it's the area of the circle at the top multiplied by the height. The volume of the dog food can is 600 centimeters cubed. So show that if you rearrange this, you get that. So let's go pi r squared h equals 600. And to get h by itself, we need to divide off the pi r squared. And notice that we're calling the radius x. So divide off the pi r squared, then that's what you've got to do. That's what we've done. Next one that we need to do is B. Find an expression for the curved surface area of the can in terms of x. X is the radius. Simplify your answer. So from page 5 of the formula booklet, surface area is 2 pi RH. So basically, because x is equal to the radius, according to this, you can, instead of going 2 pi RH, we can just go 2 pi XH. You can see x and the radius are the same thing. That's done. I hence write down an expression for A, the total surface area of the can in terms of x. Okay, so the total surface area of the can is equal to 2 pi XH. That's the curved surface area. Plus we have a circle on the top and a circle on the bottom. See, circle on the top, circle on the bottom. And remember, the area of a circle is pi r squared. So the total surface area would be the curved surface area along the side, the curvy part around the side, which is 2 pi RH, 2 pi XH, plus pi r squared plus pi r squared, which we can just call 2 pi r squared.